All right, welcome back, everybody. Today is the last lesson in Chapter 6. We're going to be talking about reasonings about special quadrilaterals. Today, we're going to be getting into the specific definitions that we know of as far as our quadrilaterals, the quadrilaterals that we have learned about. And we are going to be identifying. Okay, so the goal today is we're going to be identifying special quadrilaterals based on limited information. I'm going to give you a piece of information, and you have to tell me, is there enough information to conclude that it is one shape or the other, or if it's going to be a square or a rhombus, or both. Okay, so let's go on to our first note of the day. All right, so the very first thing I want you to do is please write this down. I do want you to write it in this exact form. So it looks like this inside your notes, and I will explain all of this. All right, so if you look at this picture here, okay, I'm going to start over in isosceles trapezoids. Okay, so if you look at that inner circle of isosceles trapezoids, you will notice isosceles trapezoids are going to be listed inside trapezoids. That's meaning that isosceles trapezoids are always going to be a trapezoid. However, not all trapezoids are isosceles trapezoids. Remember what that definition of an isosceles trapezoid is, meaning that you have, obviously you have your two sides that are parallel, and then you have two legs that are congruent to each other. Okay, so then we know that isosceles trapezoids are trapezoids, but not all trapezoids are isosceles, and then also all isosceles trapezoids and all trapezoids are always going to be quadrilaterals because they are a four-sided figure. Okay, so you will notice inside this window of trapezoids, so inside here leads all isosceles trapezoids are trapezoids, all trapezoids are quadrilaterals. Okay, and that, but however, we cannot go back under. Okay, we cannot say that all quadrilaterals are trapezoids. That's incorrect. And we cannot say all trapezoids are isosceles trapezoids. Cannot say that. Okay, going to the other side, you will notice that all squares inside that Venn diagram there, you will notice that is a Venn diagram beautifully. All squares are both rhombuses and rectangles. Okay, again, you cannot go inside, so I cannot say that all rectangles are not all squares. Okay, all rectangles are not squares. Same thing, all rhombuses are not squares. That is not true. However, all three of these shapes are always going to be parallelograms. But again, all parallelograms are not these three shapes. Okay, going back to quadrilaterals, all parallelograms are going to be quadrilaterals. So if we look at these, okay, we can all lead to parallelograms, and parallelograms lead to quadrilaterals. You will notice that, again, we cannot go back as far as not all parallelograms are rhombuses, not all parallelograms are rectangles, and not all quadrilaterals are parallelograms. Okay, so the chart, I hopefully that broke it down, and it all is based on their definitions or their the information that we know about them. Okay. So looking at this, I want you to write down these directions. You can use these directions for the next slide as well. And then write down the shapes along with the information we know inside these shapes. Then what I want you to do is I want you to explain your reasoning as far as, is number one truly a square? Do we know that it's a square? And tell me yes or no, and then why. 2, is that actually a rhombus? Give me two pieces of information being yes or no and explaining. Okay, lastly, a trapezoid. Again, the big one, not just a yes or no, but also give me an explanation as to why you think it is one of those figures. All right, so pause now, give this one a shot. All right, so if we look at this very first one, number 1, it asks, is this a square? Okay, we notice that it has 4 90-degree angles. So is that enough information to know that that is a square? What would you say? I hope you said no. That is not enough information. The reason behind that is it does have 4 right angles. That it is true, okay? But it does not have all congruent sides. This means that we know that it is definitely a rectangle, but we do not know if it is a square. Okay, because a rectangle, talking about it has all 4 right angles or all 4 90-degree angles. However, it doesn't give us any information about the 4 congruent sides. So is number 1 a square? No, it's not. We don't have enough information. Okay, number 2, if we look at that, is that a rhombus? The answer again, no. And the reason behind that is, yes, it does give us information about those angles, and that is important when looking at a rhombus. But again, what is the definition of a rhombus? 4 congruent sides. It has 4 congruent sides. Okay, does this rhombus in number 2 have those? We don't know. It doesn't give us that information. So we know it's definitely going to be a parallelogram because these two right here, 180, looking at this angle and this angle, okay, those are definitely going to be supplementary along with this angle and this angle. Okay, so we know that they are supplementary, meaning they are parallel, so we can say it's a parallelogram, but we do not have enough information about the sides to say that it is a rhombus. Okay, number 3, what do you think number 3 is? Yes or no, and why? Is it a trapezoid? Yes, this one is a trapezoid, and I'll tell you why. The reason behind that being a trapezoid is, what is the definition of a trapezoid? A trapezoid is a quadrilateral that has 1 pair of parallel sides, correct? Okay, and when we look at that, okay, we can see that 102 and 78, so 102 and 78 are those supplementary angles. Yes, they are. Okay, and if you remember that using those supplementary angles, those are also same side interior angles. Remember those theorems from way back before? Okay, so because those are same side interior angles, we can use that converse to say that this side is going to be congruent to this side. Now, we also have to state, however, if we need to look at the opposite sides here, this side and this side. Okay, if we look at those two sides that I'm outlining in black, okay, are those parallel? And the reason behind it, no. If you look at 75 and 78, these two angles here, they are not supplementary. They don't add up to equal 180. And because of that, they are not same side interior angles, and we cannot use that converse. So is this a trapezoid? Yes. And the reason behind it? Because it has 1 pair of sides parallel due to the same side interior angles theorem. Whoops. Converse. Can't forget that beautiful word of a converse. Last note of the day, if you had that, since you have the same, similar to directions as the previous 3 examples, you can just kind of rewrite this last one in your own words, and that works. Just make sure you also draw the shape with the angle measures. All right, make sure it says explain your reasoning. Make sure you have an explanation as to why you can conclude or why you can't conclude that it is an isosceles trapezoid. Pause now, give this one a shot. All right, so the question says, are you given enough information in the diagram to conclude that EFGH is an isosceles trapezoid? Again, explain your reasoning. So when we look at this, okay, what is the definition of an isosceles trapezoid? Well, first, it has to have two sides that are parallel, okay? And then second, it has to have 2 legs that are congruent, all right? So the very first thing, can we conclude that this is a trapezoid first and foremost? Yes. And the reason behind that is because we have 120 here, and we have 60 degrees here. What relationship do those two angles have together? They are supplementary. When two angles are supplementary, they are also, these are same side interior angles. When same side interior angles are supplementary, okay, that means that these two bases here are going to be parallel. Okay, so first and foremost, is it a trapezoid? Yes. Now, is this an isosceles trapezoid? Okay, in order for us to show that it's an isosceles trapezoid, we need to be able to prove that these two sides are congruent. Okay, can we do that? And the answer is yes. Okay, remember our theorems from yesterday. Remember theorem 664. Okay, if you remember that a trapezoid, if it has one pair of congruent base angles, which we do here at 60 degrees and 60 degrees, okay, then the trapezoid is isosceles. So yes, we do have an isosceles trapezoid because we have two sides parallel due to the same side interior angles converse, and because of theorem 664, which we learned yesterday. Awesome. That's all I have for you today. I hope you enjoyed this lesson. Of course, it's a math lesson. Who wouldn't? And your homework will be next. All right. Have a great day. Bye.